Module 3, Lesson 5. Objective is to subtract fractions with unlike units, where it is that we'll be creating equivalent fractions. Let's model each of these with rectangles. We have 1/3, where I'll go ahead and draw that rectangle there, and I'm going to partition it into 3 equal units. I'm only looking at one of those units, so we have 1/3. I will also model 1/5. In that second rectangle, I'm going to be drawing horizontal lines instead of vertical lines. And we have 1/5 there. So we'll divide it into 5 parts by drawing 4 lines. And we'll draw those lines horizontally. 1, 2, 3, and 4, and we're only looking at one of those parts. So we just drew our models for 1/3 and 1/5. Next, just as the same as before, we need to have equivalent fractions for 1/3 and 1/5. Our denominators in this case are not the same. So let's go ahead and work with those fractions there, 1/3 and 1/5, to make equivalent units. So here I have copied that on over with the 1/3 and 1/5 equivalent units. For this one here, we'll go ahead and draw horizontal lines. We'll draw 4 horizontal lines so that we're dividing it into 5 parts. So up here we were looking at 1/3, and now we are looking at, let's see, 1, 2, 3, 4, 5, and that's 5/15. So 1/3 does equal 5/15. Just as before with 1/5, we're looking at this here, and we'll draw 2 lines to divide it into 3 equal parts. And if we look at this here, remember this was 1/5, and when we made this here, that equivalent fraction, we are now looking at 3/15. So 1/3 was equal to 5/15. 1/5 equivalent fraction was 3/15. So we have 5/15 minus 3/15, which is equal to 2/15. So we had 5/15 for our model. Let me draw that out. So that's what we had as our model. We had 5/15, except we are subtracting 3/15 from that. So what we do is we actually cross out 3 of those 15ths. And so I crossed out 3 of those 15ths. So what we have done here is we have, and this right here then, and let me draw that there, draw a little arrow over here. This is 5/15, just as I said before, and where we've taken away 3/15, and we are left with 2/15. And then so I've modeled 1/3 minus 1/5. Let's show another example. Here we have 2/3 minus 1/7. Let's model 2/3. We'll divide it vertically, and remember we are looking at 2 of those parts. Drawing a same size rectangle for 7ths, we'll draw 6 lines horizontally to go ahead and divide that into 7ths. We need equivalent fractions. So I copied those on over, and again, we were only looking at one of these 7ths, and I didn't shade it in yet, so I'll have to shade that in first. This is, and I'll label it, this is 1/7, and here we are looking at 2/3. So using our same approach for 2/3, remember we're looking at sevenths here, so we'll draw those 6 lines to divide it into 7 equal parts. And then now, instead of 2/3 here, we're looking at 21st. That's our denominator because there's 21 there. And then we are looking at these here. And then so that is, let's see, 1, 2, 3, 4, 5, 6, 7. And then 7 more is 14. So we have 14 21st. If we looked at the numbers behind that, that's 2 times 7 over 3 times 7, which is equal to 14 21st. And we started with 2/3. So we have 14 21st here, but we can't subtract 1/7 from it unless we convert it and have an equivalent fraction for 1/7. Let's draw our vertical lines. We only have to draw 2 to divide it into 3 parts. So we have 1/7 here, which is equal to 1, 2, and 3 21st. So for our completed problem here, we have 2/3 minus 1/7. So we'll start again with 2/3, which does equal 14 21st. And then so let's model that 14 21st again. Just make this a little bit bigger here. There we go. Here's modeling the 14 21st, which is all these here. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. And then I'm taking away 3 of them. So I'll use a different color here, taking away 3. So take away, and take away. Or I could have just drawn a big X like that to take them away. What I'm left with is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So 2/3 minus 1/7 is equal to 14 21st. That's what I modeled first. And then I subtracted 3 21st by crossing them out. I'm left with 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 21st. Your turn to try. Let's try 1/2 minus 2/5. Pause that video. Started off with a couple of rectangles, one for 1/2 and one for 2/5. Those rectangles should be the same size. For 1/2, you would divide it into 2 parts, and you're only looking at one of those parts. For 2/5, we'll draw horizontal lines. For 2/5, draw 4 lines to divide it into 5 parts. And we are looking at 2 of those parts. So this is 1/2, this is 2/5. And remember, we're subtracting them. We need to get equivalent fractions. So we'll take this first one here and draw the horizontal lines, and we have to draw 4 horizontal lines. Let's use a different color. Easier to see. 2, 3, and 4. So now we are looking at 1, 2, 3, 4, 5. This is 5/10. 1/2 does equal 5/10. The other fraction was 2/5, and we are looking at an equivalent fraction for 2/5 where we're also talking about tenths. 2/5 should equal how many tenths? Hopefully you got 4 tenths. Did you draw those lines correctly? You just had to divide it in half. So if you're looking here, sure, 1, 2, 3, 4, and there were 10 equal parts there. Now, all we did at this point, when we were looking at our answer here, and we were modeling the 5/10 minus the 4/10, we started with 5/10. So we had that same model there where we were looking at that, and we were shading those in to be able to get 5/10, right? And then we were crossing out 4 of those tenths. So when we cross out 4 of those tenths, crossed out 4 of those tenths, what are we left with? We're only left with 1, or 1/10. So 1/2 minus 2/5 does equal 5/10 minus 4/10, which does equal 1/10. Your key is to get equivalent fractions so that you can go ahead and show your subtraction. What you're subtracting is the part that you cross out.